In this video, we will be discussing why ITRC recommends screening petroleum vapor intrusion sites based on source building separation distance. In concept, the risk of vapor intrusion is low for buildings that are separated sufficiently far from a vapor source located in soil or groundwater. Source building separation distances have been routinely applied as an initial step in vapor intrusion screening. This screening is performed prior to the comparison of site-specific chemical concentrations to risk-based screening levels in soil gas or groundwater. In the past, however, the source building separation distances used for petroleum vapor intrusion screening were too large to be effective, and they did not meaningfully account for vapor transport in the VATO zone. As a result, numerous petroleum vapor intrusion sites were being investigated only to find out that there was little potential for the hydrocarbon vapors to enter overlying buildings. This video will present the theory behind and importance of screening petroleum vapor intrusion sites based on source building separation distances. Vertical screening distances for petroleum vapor intrusion are formally defined as the minimum thickness of VATO zone soil that's necessary between a vapor source and soil or groundwater in the base of a building foundation for the hydrocarbons of concern for vapor intrusion to biodegrade below risk-based screening levels in shallow soil gas. What's nice about the method is that it incorporates biodegradation into the screening process, which is not possible if screening solely based on comparing chemical concentrations to risk-based screening levels. The screening distances recommended by ITRC were empirically derived from big data studies that involved evaluations of thousands of groundwater and soil gas measurements from hundreds of petroleum release sites evaluated by the US EPA and Lavas et al. In 2013. The screening distances derived in these studies vary primarily as a function of source type, site type, and hydrocarbon type. The screening distances recommended by ITRC for LNAPL sources are 15 feet if it's a petroleum UST site and 18 feet if it's a petroleum industrial site, for example, a refinery, pipeline, or terminal site. For dissolved phase sources, the screening distance is 5 feet regardless of site type. These screening distances reflect the distances above a petroleum vapor source at which the concentrations of all petroleum hydrocarbons are attenuated below common risk-based screening levels in soil gas. The screening distances recommended by ITRC correspond to those derived for benzene, which were the longest of any of the hydrocarbons evaluated that are typically of greatest concern at petroleum vapor intrusion sites. Source building separation distances have routinely been applied as an initial step in vapor intrusion screening. Prior to the publication of ITRC's PVI guidance in 2014, a handful of states published screening distances for petroleum vapor intrusion that were less than the 100-foot distance US EPA recommended for chlorinated vapor intrusion. Although these distances were less, they still did not effectively improve site screening, nor did they meaningfully account for vapor transport, and particularly biodegradation, in the VATO zone. So again, if a site can't be screened out based on distance, then one defaults to screening based on comparing site-specific chemical concentrations to risk-based screening levels. In most cases, the risk-based screening levels are derived from application of the Johnson-Ettinger 1991 vapor intrusion model, which does not account for biodegradation in the VATO zone. As a result, the risk-based screening levels for chemicals such as benzene and groundwater were typically in the low part per billion range. Because such concentrations were easily exceeded at petroleum release sites, essentially all these sites were being assessed for petroleum vapor intrusion, regardless of whether a building was actually present on site or it could be present at some time in the future. The site investigations that ensued following site screening typically involved measurements of hydrocarbon concentrations in soil gas, which were commonly found to be orders of magnitude less than the risk-based screening levels. Hence, lots of sites were being investigated for the potential for vapor intrusion where little potential risk actually existed. At sites where soil gas data were collected, it was common to find hydrocarbon concentrations in soil gas decreasing by several orders of magnitude within a short vertical distance above the vapor source. This location also coincided with increases in oxygen concentrations in soil gas by several percent. Such occurrences are direct evidence that petroleum hydrocarbons aerobically biodegrade at faster rates than they physically migrate upward by vapor diffusion. Hydrocarbon vapor samples collected below the interface typically exhibited little or nothing in the way of bioattenuation in the vadose zone as compared to vapor samples collected above the interface, which would essentially be all or completely attenuated. This behavior can be contrasted by a more gradual decrease in chemical vapor concentrations commonly observed in vadose zones at chlorinated vapor intrusion sites. The behavior observed in the vadose zone at petroleum hydrocarbon sites also makes it nearly impossible to relate source vapor concentrations in soil or groundwater to vapor concentrations in shallow soil gas or indoor air. The distribution of hydrocarbon vapors at petroleum release sites also lends itself nicely to screening based on source separation distance. So long as there's sufficient thickness of vadose zone soil between a vapor source and a building foundation for aerobic conditions to develop, then the risk for PVI becomes negligible. Lastly, hydrocarbon concentrations collected just above the water table at sites with dissolved phase sources did not compare well to the concentrations measured in groundwater, even if the soil gas and groundwater measurements were concurrent and co-located. For example, it was common to find equivalent vapor concentrations for chemicals like benzene in deep soil gas above both a 5 and a 5,000 part per billion source in groundwater. The soil gas concentrations collected near the water table were also orders of magnitude less than what would be predicted by Henry's law or equilibrium partitioning, implying that biodegradation played a significant role in reducing hydrocarbon vapor concentrations that were associated with dissolved phase sources. So taking all this information into account, it's easy to see why ITRC recommends screening based on source building separation distances rather than risk-based screening levels. And that concludes this video. If you're interested in obtaining additional information on PVI, LNAPL, or TPH, please visit the following ITRC websites, which contain links to both guidance documents and fact sheets.
The Interstate Technology and Regulatory Council is a nonprofit research program of the Environmental Council of the States. ITRC is a state-led organization composed of over 1,000 members from state agencies, federal government, tribal and international organizations, the private sector, academia, and community stakeholders. Members participate in technical teams which produce guidance, tools, resources, and training materials. If you'd like to be a part of ITRC, please visit the ITRC website at itrcweb.org. You can register for teams and learn more about how you can be an active member. ITRC's usage policy is available on the ITRC website. If you do plan to use ITRC materials, we ask you to review that policy in detail and be sure to credit ITRC. ITRC does not warranty the material nor endorse any specific products.